I am normally actually the plain maintainer, but I've been doing a lot of AP perf stuff lately, so I've kind of got the opportunity to do this, do the update for AP perf. So it's actually on the wiki now, has its own web page entry. We have our own logo, and ta-da, that's what it looks like, AP perf. Um, and here we are. Oops, next page. Where's the next page? Here. Okay, so what is AP perf? It's one of our new things. So I want to make sure I share with what it is. It's a relatively new project that we have offered within ArduPilot. There's several different hardwares that are off the shelf. I'm going to talk about all the features of it, what's now, timeline, things in the future, how to get to use it a little bit, some development details of how to dive in and start using it and develop your own things, and then depending on questions or whatnot, maybe I can do some demos and compiling it and something like that. All right, so what is AP perf? Basically, you just build ArduPilot without a vehicle. Normally, if you build ArduPilot, you get all these other things with it, like object avoidance and GPS drivers and IMUs and all these things. But you have a main loop that it runs through to basically check serial ports and all these sort of services it's running. So what this is a much more minimalistic version of that, where we have it has its own main loop. So it's basically you compile it as AP perf as the target, and it's just its own main loop running just the little small tasks you want. That allows you on the build to give you a much smaller build size, and really cater to smaller memory footprints, smaller or slower CPUs, and just basically do just the little things you want. And this allows you to make hardware that's very specific to just do a little task and then leverage all the infrastructure that we have with ArduPilot. You get serial ports and buffers and DMA and UAV CAN and all the protocols and all these other drivers. So there's a few products out there that use an F103, STM 103. And it can build for that, but you're really going to have to finagle it a little bit and trim things down. But basically, you want to start with at least 256, and that runs comfortably a few features, no problem. But if you're going to do it, I'd actually recommend doing like an F4 with 256K or higher, just to future-proof yourself. But if you're making a given hardware for just a certain task, you can get by with 256. And because there's so much hardware out there already, you can actually take a Pixoc 1 or Cube or whatever, just off-the-shelf autopilot, and use it as an AP perf hardware target and do development from there. And all you need to know is just what pins are connected to where on your hardware, and you're done. Here's some examples of some off-the-shelf hardware you can get. Hex is coming out with some products that are using it. So they've actually been contributing a lot of the code to build out a lot of the infrastructure on it, which is really nice. That's with help with the Sid and Michael DeBro, or Michael Oborn. And so and Robotics has been one of the first markets, I think. They had the F103 and they came out with a 303. Now they're coming out with some newer products. J-Drones has some, I think CUAV does, but Maytech I know has a GPS product. It's fairly easy. If any manufacturer's already made a STM32 based ArduPilot compatible thing, then it's fairly trivial to make an AP node. One of the reasons we actually kind of went down this path of making AP perf was because manufacturers or users were using ArduPilot as a vehicle. So you just load in Copter into a Pixoc 1 or whatever target, and then it'd be right along as login sensors or being some sort of node to do something. And it was some people were hacking at that to make that work, and we realized just bring that in as an actual feature. So here's all the different kind of libraries that we and features that are available today. So just recently we did a Tribios update, and that's part of that allows us to have multiple cans. So we can have like CAN 1 and CAN 2 as of just a month ago or two, it only had single CAN support. So now it has multiple CAN, just like our other vehicles offer, as in CAN 1 and CAN 2 physical ports. You can make a node be a GPS. So if you have a U-Blocks or whatever kind of receiver, it can plug into your node, and then primarily the nodes talk UAV CAN back to your vehicle, and so it just emulates as a UAV CAN GPS or a UAV CAN magnometer or a barometer or a whole list of different things here. So these are all the libraries that we've brought in and added support for, and they are generally it's a feature to UAV CAN converter. So I think we've added a few UAV CAN specific packets, but a lot of these are already supported in the spec as is. But it gives you a nice little tool, like for example, RC out. With that, this allows you to have multiple CAN ports on your vehicle, and you can via just CAN or run them out to some other target, and then that can then turn into 16 GPIOs or whatever out on the end. So it's all controlled over CAN, and all the hardware's kind of done there. You can just put a PICSOC or whatever on the end. So one of the earlier features we added was the LED and buzzer type support. And so Toshiba and NCP and NeoPixel, those were and buzzers, those were added as in you can do them individually and it'll fit in the 128K. But if you basically add any other features, it kind of fills up your 128K. So adding the notify library is the proper way. It takes up more memory, so it doesn't fit in the 128. But doing that, you basically have all the features in the notify library. So that includes your on-screen display stuff, whatever LEDs and NeoPixels and RGBs all at the same time, and buzzers. In fact, the buzzer itself I've used on the vehicles I use at Kraus Hamdani Aerospace. We don't have a buzzer on the aircraft, but it's nice to know when it reboots and stuff, if you're doing firmware updates or whatever. So everything on it is CAN as much as possible on all of our new development. And so I can just plug in a cube on a carrier board to anywhere on on the end of the wing or something, and then suddenly I have a buzzer that I can use to know when it reboots, which is kind of convenient. And all the nodes work with the UAV CAN DNA. So that's the auto assignment for the address or the CAN ID. But things like ADSBN parameter. I have parameters twice there. So you can configure all this through parameters, and I'll give an example later of how to do that. There's a Mission Planner has support for talking to this over serial or USB or TCP and UDP. That sounds a little funny, but I've been using some serial to IP converters, and then I can actually do an SL CAN on a serial port, feeding into Mission Planner, and so over UDP traffic, I can do firmware updates on my peripherals, which is just amazing, and configure them and all that. The whole battery monitor is there, so you can actually this as a standalone thing can be used as just a smart battery. So you'd have lots of different batteries or inputs or calibration, whatever. You can just put a little small chip on your battery, and then suddenly you have a UAV CAN compatible battery. So that's nice. You can create the names of in your hardware defined. You can create the title. So when you show up, you can see all the different peripherals on the bus, and so you can name it whatever you want. And so on. There's airspeed, rangefinder, and so on. There's all the typical things we offer that right now. Things we're missing, however, there's no SD card support. So there's no logging. There's debug that's over the UAV CAN, but you can't write anything to the SD card yet. So there's just no storage there, which means you don't have things that also use that, such as scripting and such. There's no Mavlink, sort of. So there is Mavlink support, for example, with the ADSBN. So this is, with ADSBN, it's talking Mavlink to like a UAVionics ping receiver. but it's basically just looks for that one packet and just parses the one thing. So the whole chunk of reading packets is not normally in there. So it's kind of a one-off. And so I think there's actually two different places we parse for packet, but we're not normally processing packets at this point. There's been work done on IMU as an external AHRS, but I don't believe there's anything in there in master as of today, but I think it's pretty soon. But that's going to be a giant target where this little node can be placed anywhere, and it can become a triple redundant IMU sensor or whatever, just as a standalone node. So that's really nice. UAVCAN 1, of course, ArcherPilot doesn't support that quite yet, but that's definitely on the roadmap of wanting to be done. So we're having to use some of the older protocol, the version 0.9 and the DSDL, the packet descriptions are all from the older one. So we'd like to change it to that, but we're on the 0.9 now. ADS-BN is supported, but not ADS-B out. So that's a kind of a weird one-way thing that that's asymmetric. And FDCAN. So this is the fast data where you can send data at 8 times faster. Actually. So that's coming in with some of our new Chibios updates, and we'll be adding that soon. It's kind of in the pipeline, but it's something would be really nice to have, but it's just not there right now. But coming soon. Some of these in progress things that I know are under development is CAN protocol translators. For example, I have an ESC like a KDE CAN. You could have a KDE CAN ESC, and but my autopilot is using two UAV CAN ports to talk to a whole bunch of different peripherals. I don't want to dedicate a CAN protocol I don't want to dedicate a whole port to a protocol. So my AP periph, it can have one port coming in as UAV CAN, and then the second port is KDE CAN talking to the hardware. So it can basically translate there. So there's been work there. It's not quite ready to go into master, I think, but there's pull requests available and stuff. MPPTs is kind of a fancy battery that I'm using it across Hamdani Aerospace. That's for solar panels, charging batteries. It's basically, it looks like a smart battery, but it's charging from a solar panel. So it's a smart solar panel instead of a smart battery. Output for 32 servos. There's technically support in master for that for vehicles. So it's kind of halfway there for the AP periph nodes, but I don't think there's any hardware that quite supports it. But I believe it should at least accept the messages for it at this point. So it's kind of halfway there. Right now, the hardware-defined.dat is how we describe all the hardware when compiling for Chibios, and it's a little confusing because the hardware-defined bootloader and the app are a bit redundant. So I have a branch where I've kind of combined that into a hardware-defined common, and then your hardware-defined.dat is actually just it includes common, but then gives you just app-specific things, and then your bootloader is just bootloader-specific things, but your hardware is all described in the common. So you don't need to copy things back and forth or have them different or have too much redundant stuff. It's easier to maintain that way. And that's actually more of a ArcherPilot in general, like an infrastructure that I'd like to kind of move forward with for all hardware defines. It's just problem of that is it affects every hardware that we have, so it's hard to test those to confirm they're working. So we might need to do those one at a time or something. But that's those. I have working versions of those on hardware that I'm using. IMU nodes. I know the IMU node. There are some people that have versions of that going out or that have prototype hardware that they're using this for. So I'm sure it's just a matter of time that they'll get it as a native feature. Native ESC, yeah. So David May is a new hire here at Krauss Hamdani Aerospace, and he's actually working on ESC as a standalone native device that's based on AP periph. So it would be actually adding a new feature to ArcherPilot as a as an ESC. So we'd actually have an open source ESC that can run our algorithms, but also run all of our infrastructure and UAV CAN and serial ports and feedback, and also act as a battery to measure currents and all that. So he's working on that, and really excited about that. So that'll be a big plus for AP Perif as far as ArcherPilot being like, a brand of ESC, sort of, or at least the software running on it.
So I'm curious, Tom, is that VESC based, or is that a new implementation of the ESC, is underlying maths and control of ESCs?
Well, so David May is doing this as he's just finishing up his university, his engineering degree, and so he's doing this as a senior design. And so he's doing the maths and whatnot as part of his project. We've looked at the VESC, and it's a bit confusing as far as how it all kind of works. It's not very clear. But agreeably, I haven't looked into it deep enough to really spend the time to understand it. But so I'm thinking it's not going to be based on that, but it's open source, so it's one of those things where we could look at to see if there's some things we can learn from it. So
the other one that's worth having a look at is the newly released AM32. I don't know whether you've seen that at all.
AM32, no, I haven't heard of that.
It's a new open firmware for BLHEL32 ESCs, just recently announced, and might be worth having a look at as well as another basis for the underlying maths. It supports things like D-shot and bidirectional D-shot already, which are, obviously, if we're doing a perif ESC, we're going to be doing CAN as the primary protocol, but it's got quite a few nice features.
Yeah, I mean, BLHeli is also open source on some of their systems.
The BLHeli, yes, but that's in assembly only. I don't think we want to do an assembly-based ESC, and it's very hard to follow assembly.
Yeah, I was going to say you'd have to see what it's doing, but you can't just copy and paste the code.
Yeah, I've looked through BLHeliS, and it's really quite hard to follow. But the AM32 is written in C, as of course is VESC, so they're a better basis.
Yeah, well, I mean, this is it's kind of just starting the work on this right now, so I'm sure he'll see this video and have your great ideas and look into it further.
On just to add to that, FOC drive is a big win on an ESC if it can be, if whatever we're doing supports the basis of that, like, and that VESC does support FOC drive.
Yeah, right. So that's the idea, is to leverage all the technologies we can and be open source in a way that's very adaptable and easy to integrate into systems.
I think FOC. I mean, do you mind a little bit of an aside and discuss this a bit, Tom, during the middle of your talk? Would you like to leave it to the end?
That's okay. What's next is the future work. Yeah. So
yeah. So it's like FOC is I think a very worthwhile feature to have, but I wouldn't want it to be required as in the only. That's been some of the weaknesses some of the ESC firmware have had, have been only FOC, and that can be quite difficult to tune and get it to work on different combinations of motors. So having like trapezoidal as the base, but then optionally put in FOC, is there any particular reason why that wouldn't be doable, Leonard?
Oh, well, the reason why I like VESC is it does exactly that. It's got, you can set it up, trapezoid, FOC. It's also got a lot of automatic tools in there that allows you to use the ESC to make the measurement on the motor to define the FOC. So there's actually a tuning process, like an auto tune. You effectively go through, you connect the motor, you go through and you run a test, and it goes through a test on the motor to measure the required components to build the FOC model that you can then. Interesting. So it takes about 5 minutes to set up a motor for FOC using a VESC.
Okay, right.
It also supports sensor feedback into the ESC. So you can add sensor, like a positional, like a Hall effect sensor to take the position of the motor and do a sensor driven motor. So basically VSC does like all three of the main sort of drive topologies. So
right. Interesting.
Yeah. So
We should probably have a separate chat with David May, and because I know Sid's very interested in this, and Leonard's obviously interested, and I'm interested. I think a whole bunch of us are interested in a RGPilot hosted ESC project, particularly with CAN.
I can tell you that ESCs are the single biggest barrier for
reliability,
commercial aircraft, and
efficiencies.
And if we were able to sort of have this firmware that we could keep on driving forwards, I wouldn't be surprised if it went the same way as the autopilot in the longer run, where basically if you wanted a reliable industrial aircraft, you had to run RG ESC. You know.
I think it is an absolutely key thing, and I'd love to have a chat with David, and Sid and I have been discussing it a little bit. It's something that I think it's very worthwhile putting effort into. Test infrastructure. We need really good testing for ESCs. It's hard to test them really well, as you well know, Leonard.
Now keep in mind that this is one of those things where it's baby steps to get something new like this working. Day one, just open loop is great, and then you can add to it, right?
It needs to have the right sort of structure to be able to do some of the others. But be a really good discussion. We should probably let you get on with the rest of your talk now, Tom. It just piqued my interest very strongly.
What's that, Peter?
Oh, I'm sorry. I should mention that we have previously had a fairly active open source attempt at doing this called Open Motor Drive, which I know very little about, but could potentially be another resource.
Yep, that's true.
That was FOC only, I believe, and it was quite difficult to tune, was my memory.
Yep, but fixing that might be better than starting from scratch. Sorry, Tom.
Yep. Okay. Yeah, and that's with the John Challenger.
Right. All right. Thanks, David. Thanks, Tom.
Future work. All right. So things that we'd like to do that are roadmap type of things. Promote this as a first-class citizen. So right now it's actually living in tools/APPRIF. So we'd like to migrate it over to just into its own folder, kind of like how plane and copter and rover are. Also, there's a whole lot of code being handled in the can.cpp file. So we should probably try to abstract those out a little bit more. A lot of the features are wrapped around pound if defines to enable it. So it's just so the file size is real small. But a lot of it's kind of just thrown into this can. It's still commented or if defined out, but it's a lot of the handling is kind of happening in one place. So we might want to rearrange this a bit. So that's it works right now, but it's kind of getting unwieldy as we're adding this onslaught of features. And with an onslaught of features, you also get lag on the wiki, on the documentation. So we need to make sure we keep up with that and get that going and update the feature list. And one of the problems we have right now with that is we don't have the param descriptions. So in normal vehicles, they're semi self-documenting by each param. We have the description and all that, and then that we have on the wiki. We scrub those files and post it, and generates that on the website. So you see that for various versions of our released firmware, and so it kind of other GUIs can pull from that. So when they see a parameter, they can match it up to a whole paragraph description, and none of that happens right now for APPRIF. So it's a bit, you kind of have to dig in the code to look. Most of the parameters have description stuff. So if you look in the code, you can see all that stuff, but it's not on a web page or anything quite yet. Also, it would be nice that a nice to have feature is on the vehicle when it boots up. It would be nice that you can embed a version of your node code into your vehicle code. So when it boots up, if those don't match, it just pushes that version out. That allows you to always have a repeatable system where if you update one system, it then updates your whole system. You don't have to go through each one and possibly miss them or whatnot. Also, the incompatibility problems where if one's on one version, the other one's not, maybe it doesn't work the same way or respond to it. You can have regressions and such. So it'd be a nice feature to optionally do this, so it can scan everyone's firmware and make them all new, or at least make them all match. So you always have a vehicle code matches this node code, or I shouldn't say they match, but I should say it matches the expected firmware. All right, and then also just implement more and more stuff. We have lots of other libraries that we could add in there. Our library folder has gotten quite long, so it's like 100 different things now or something. So we can just keep adding more features into APPRIF as they become necessary or needed. So how to use it? There's Mission Planner has added a lot of really good support to it. So if you go to the setup tab, and then go down to UAVCAN, there is this page, which is normally blank, but you would click on the SL CAN. SL, I think, is serial link CAN or serial something CAN, and that's basically wrapping the CAN packets into a serial friendly thing that you can send over the serial port, and so other GUIs can ingest it or talk to it over a serial port and interact with your CAN bus. There's two main tools for that. There's the UAVCAN GUI tool, and which is from the uavcan.org folks, and Mission Planner. On Mission Planner, if you plug in a device like a cube, it gives you two different serial ports. You'll notice it says like Mavlink or SLCAN. So that's how you use it on here. Is on here it says on the top right it says COM20, but if you clicked on it and pulled down, it would actually say COM20, or it'd say or Cube Orange SLCAN 20. When you do that, you automatically start getting all this data. So this is actually what an example of other devices. So I have a HERE GPS and a EMLID Edge GNSS GPS receiver. So I have two GPSs there. I have this one here, which you can see is this is the autopilot itself, so it's kind of seeing itself. And this is another one. So I have a Cube Orange periph. So this is actually running a Cube Orange, and it's looking at a different Cube Orange that's running the periph firmware. So you can see all these things, and the menus light up. And you can look at all the parameters. So these are the parameters, how you configure things. You can read, write, and all that sort of stuff. But also from this menu, you can click to upload a firmware. So just you go menu, and then I think it's update, it says. But after you compile the code, you send it the .bin file, and it will firmware update the devices, which is nice. You can communicate to this. So those are the two software systems, but on hardware, you can use any ArcherPilot hardware. I'm not sure what version we started that, but we've had it for a few years. So circa 2017 or 20 or so, we've had this SL-CAN support, and that allows us that with any ArcherPilot that has CAN, you can plug it into your bus, and it'll populate and look at all the CAN bus around the screen like this, or on the UVCAN GUI tool. There's also something from Zubax, who also, same folks that did the UAVCAN GUI tool. They sell something called the Babel, which is a similar thing. It runs the SL-CAN protocol so you basically get over a USB port, right? So you can get it's a CAN to USB converter, so you can see the stuff on the screen. As far as development wise, we recently added a soft in the loop instance of it. It's somewhat minimal now. I think it only just runs the GPS. If you want to do testing on it, you have to add in the features manually right now. But there is support for that, so it is there, and you can connect to it locally and see all the data and interact with it and do that work. Bootloader wise, it embeds the binary of the bootloader inside the vehicle, or inside the app firmware, just like the vehicle code does. So you can update your firmware, or update your bootloaders. And the bootloader itself is a little bit bigger than normal bootloaders. because all the interaction on here is happening through CAN. So the whole CAN stack has to be in there. So that pushes the file size above 16 kilobytes. So in most of our targets, 16 kilobytes. For like F4s, 16 kilobytes is a block, so that we can run it that big. But on an H7, the smallest block is 128K. So it doesn't matter if your bootloader gets big, it all takes up the same amount of space, takes up one page. But for targets like the STM32F3s and 4s, if you use an AP perif bootloader, you have to make sure that the bootloader size is, you reserve enough space to be at least 24, or I think it's 26K, or just 32K, whatever. It has to be more than 16, basically. So depending on your target, you can look at it, see how many pages are available for that. But as far as development, it's fairly easy for a developer to, if you want to use, if all the current features are okay with you and you just want to make some hardware, you just you make a new hardware define.dat, and then you just include like an F303. Let's say that's the chip, you include the F303 perif hardware, and that describes kind of a generic system, and then you can kind of just turn on features from there, or you can modify it to change pins around or whatnot. But it gives you a nice head start. So several other products actually do that. They include that and then just tweak a few things. The files are actually quite minimal. So we have inside the Arduino tools, AP perif, this is it. This is the whole folder that runs everything for AP perif. You'll notice that the can.cpp is 71K, but everything else is pretty small. And that's just a testament of the infrastructure that is leveraging in Arduino. It's literally just including a library, like you'd say in the apperf.h, you would say you'd include AP rangefinder, for example, and it just sucks in the whole rangefinder. Now you just run the rangefinder update and the init, and magically you got a whole rangefinder system now. All the drivers and all that are there. So it's pretty amazing the infrastructure you get for the minimum amount of work you get. And then it's just all the work you need to do is just adding that one feature. That's why, for example, the ESC talk we had earlier, you'd make that, you add a new feature and just run the update on it. There may need to be something special for DMA handling for fast sensor feedback or whatnot, but all that's there, all in place. And you can even spin off your own threads and all that, just like any other library does. And in fact, all the libraries do that right now. So for example, like I said, the AP rangefinder, if it's an I2C bus, for example, all that comes in already, and it spins its own thread off for the I2C bus it's on, and all that. All that's in the library, right? This has all been abstracted out into their own libraries in such a modular way that AP perif just includes it and then calls update, and ta-da! So quite amazing. And that's all I have. I don't necessarily have a demo to show, but I can go through the steps to show some hardware defines and or compile it and just show what's necessary to kind of tweak one. I was wondering from the audience if anyone had any requests on what they'd like to see.
G'day, Tom. There is one from the audience asking how hard it would be to add OSD to a perif node.
I haven't tested it, but I believe that's already there.
Okay.
Yeah, you just include you enable AP perif.
No, we can do MS. Well, we can do MSP output, which is.
Oh, I'm sorry. OSD.
OSD on screen display. We don't have in any of the peripheral nodes yet. It would be certainly doable, but though the problem with that is populating all of the fields, right? Because the OSD wants to have a whole lot of data. So unless the peripheral node can get all of the data to populate the fields, the OSD is going to end up being pretty sparse. So there's a whole lot of precursors. We would have to be publishing that state information onto the bus from the autopilot. So it's certainly doable, but it's sort of not all that useful until you have all of that state information published onto the CAN bus in the first place.
Yeah,
And
one
all of
limitation.
that information is basically all of RGPilot state, really.
Yeah, so one limitation
we can have
we-
pieces of it, but
One limitation we have is actually all this data has to get squeezed through the UAV CAN port to it, right? From vehicle to
Yeah.
the node, it has to tell it everything. And there is information like that. That's essentially your HRS information that gives you your location, heading, and all that sort of stuff.
Well, if you published Mavlink to LIM down and encapsulated on UAV CAN, then you could have the OSD in the AP perif.
Yes, so that's one thing that I've actually done that a couple of years ago. Was doing a Mavlink over CAN translator, or not CAN, the tunnel, I should say, so that a device on the other end only talked Mavlink, and it just accepted the CAN packets and just popped them out as Mavlink.
Yeah, it's not high bandwidth, right? It's 38K, 56K, but that's what OSDs were before we integrated them on board the chip. They were Mavlink dongles.
Yeah.
So you can get almost everything normal person would want in an OSD with the Mavlink to LIM.
Yeah, which reminds me, back here, available today, I think I said OSD on here. OSD, yeah. So I don't mean OSD on here. What I meant to say is the OLED screens.
Right. Okay.
Yeah.
Yes, you notify on the OLED, although again, what information you're going to display on the OLED, because the notify subsystem, I mean, things like buzzer and things and LEDs, no problem, because we publish that from the autopilot, but we don't at the moment, for example, publish the attitude. And we don't publish a lot of other information that would normally be displayed on an OLED or on an OSD. And I'm not sure going the Mavlink route, encapsulating Mavlink is necessarily the best idea, because we end up with a fairly complex parser of that Mavlink, and the original OSDs that were based around Mavlink weren't as good as our current OSD. They didn't provide the information in the same level of detail, and they were a lot less efficient. We constantly had little troubles with exactly what data they could display and how they could intuit it, and coping with planes versus copters versus rovers, etc. So it'd be an interesting one to think about. But my first reaction is that I'm going the Mavlink route probably isn't the right way to do it.
Yeah, well, I do have a pull request from 3 years ago when I tried that, and
I think supporting a serial service is very worthwhile. I think we should go back and revisit that. But it shouldn't be a Mavlink service; it should be a serial service. And so it's not Mavlink specific. You should be able to do basically a serial port expander is far preferable. And we did have a version of your PR, I think, Tom, that did that. That did it as a general serial port expander.
Yeah, in fact, I added that to the UAV CAN spec. So there's a thing. I think I renamed it, but at one point it was called tunnel. So you could tunnel just bits, and so you can make it be SPI or I2C or whatever data you want over that tunneling.
Yeah.
I think they call it bridging now or something like that, but yeah. Yeah, okay, so how about we take a quick look at, or how are we on time? We're at
still got plenty of time. So we're scheduled to finish this in another hour, because we finished the first talk a bit earlier than expected. And so we actually have plenty of time. So if you want to, but we don't have to use all of that time. We can take a break, or we can move on to other discussions.
Well, let me pull up a hardware defined as an example to just demonstrate that a little bit. So let me get this out of the way. I will go here. Let me see. I have the Zoom thing hiding. Let me try and hide this thing. It's not hiding. Oh well. So here's an example of the hardware defined for F303M10070, which is a new product that's coming out from MRO. So it's a new GPS device, or GPS, and well, let's find out what it does. So what they did is it's an F303 STM32. So on this file, you basically just create this directory, and then you had an artdefine.dat. And because it's already using this, it has a similar pinout. They just copied that, just included that, and we'll look at that in a moment. And then they named it, so they just called themselves this. So it would show up on your mission planner or whatever list you're using for your GUI. So this is what it looks like. And then they just define the SPI and barometer, just saying what address to use. So it just defaults to that when it tries to talk to it. And then this is the guts of APPref. You just define, enable these features. So it's turning on the mag library, it's turning on the GPS library, and it's doing the RGB LEDs, but without notify. So that means it only adds that one feature as opposed to the whole library. One downside of doing the whole library is you get a whole lot of parameters of a whole bunch of stuff, where doing like this, you hard code to say, just do this, just do this one pin. And as well as the airspeed, right? So this one device is going to be capable of looking like all these devices all at the same time. So it'll be, you can hook up your barometer to it, and I'm sorry, your differential barometer for your airspeed and whatnot. So then let's look at what it's including here. That is this guy here. So that's the F303 perif. So this one describes a bit more of the details. This looks like other hardware defines. If I go back to this for a moment, you notice that this is all that M Robotics had to do. They did this. They wrote this part here to describe what features they wanted, and suddenly they have a new product that magically does all these things. And they just made sure that they connect the dots on the schematic, and the dots just matched previous versions of available hardware, but they could have just wrote the whole thing by themselves. Look at, copy this data and just remapped it to other pins, because there's no pin map in here. You notice they use the existing one from here. So it was fairly trivial to just say this device does these features and ta-da, you're done. There's just in a few lines of code.
It's worth spending a minute on the DNA, the line 6 and 7 there, where it discusses the choice about dynamic. DNA is dynamic node allocation. And that whether you choose 0 or non-zero is quite a subtle choice. And so some of the devices have chosen non-zero and some of them 0. Do you want me to describe that, or do you want to describe what the reasoning behind that?
Well, yeah. So it's the why don't you
sure.
on that?
So it basically this is something that the vendors do struggle with a little bit. So it's worth understanding. You can either set up a peripheral node so that it will automatically be assigned a node ID on the bus by the flight controller, because the flight controller runs what's called a DNA server, dynamic node allocation server. And if you set it to 0 there, that means it doesn't start up with a node ID, and the parameter node ID starts as 0, which means it'll sit there waiting on the bus until a DNA server assigns it an ID at boot. And that's the default for most of our peripherals. And if you want to be able to connect multiple of the device on the bus, you have to do it that way. So for example, if you're selling CAN bus GPS modules and you want your users to be able to trivially just plug in 2 of them, and they automatically get assigned different IDs, then you'd want to default that to 0. But some of our vendors have deliberately chosen non-zero, which means it comes up with a fixed ID, which makes it easier for some users and harder for others. The advantage of using non-zero is the peripheral doesn't have to do CAN bus. And so, for example, Maytech did this for their GPS module and airspeed module. And the reason they did that is the peripheral device, the Maytech GPS and airspeed sensor, also supports MSP output with no CAN bus. So if I've got one of these airspeed sensors here on my desk somewhere, or maybe I don't have one handy, they want to be able people to be able to use it with only the MSP protocol and no CAN bus. And so if you had DNA enabled as set node ID 0, then it would never come up on MSP because it'd be sitting there waiting forever for a node ID to be allocated. So you couldn't use it with just MSP. And the other subtlety in this, if you do dynamic allocation, it's a little bit harder for end users to work out which, for example, which GPS is which can really matter if you've got one GPS on the end of one wing and the other GPS on the end of the other wing, and you're going to want to get the positions right. Then the first thing you'll probably want to do when you buy those GPS modules is to actually change the node ID parameter, which I think Tom is just showing there now. If you want to bring up the parameters from one of those ones, Tom,
Sure.
go and set so that you actually set the node ID under M. There should be a node ID parameter there, so
I don't think it's in here. It's not a parameter.
Well, there is a node ID parameter. There should be.
Well, for a vehicle there is, but I'm not sure. Oh, you're right. There's
CAN node. Yep. So that's the node ID parameter. Yeah. So it's doing DNA. It's 0. But if you want to actually have multiple GPSs and you want them to have non-zero positions relative to the center of gravity, then you'll want to set that node ID on each GPS so that you can then assign positions in a stable fashion. So anyway, that's the little subtlety about the DNA configuration in AP-perif nodes. And you've got to actively make that decision as a vendor as to whether you want to grab one of the 127 possible node IDs as a fixed ID, or whether you want to be able to just do it as dynamically. In most cases, you want dynamic, but there are some cases like the Maytech one where the right choice is to make it a fixed ID because that makes it easier for the majority of your users.
Yeah. So for example here, so I just connected to a vehicle here. So these are all the cans for the normal vehicle. You can, for a GPS, because when you have two GPSs, you can use that as a heading, but you need to know which one's left, which one's right, or you don't know swap the positions and all that. So you can say this one here, this one's definitely, when you boot up, it needs to be node 1, or I should say GPS 1 needs to be this guy right here, and GPS 2 needs to be this guy right here.
Yeah. And the support, so SID has been working on patches to make it easier then to assign the GPS node IDs to a particular GPS ordering in our GPS library to make that position assignment easier, because at the moment it is quite tricky to get that right. Basically because the CAN nodes can come up in any order. We can't control what order they appear on the bus. All right. So anyway, I just thought an aside on DNA would be useful, Tom.
Yeah. So if you notice here, there's a F303 Kraus device, and that is just an MRO node, little F303 node. And so I just made my own and added the features I wanted to, slapped in it has pads for I2C and SPI and whatever. So I use it for my own purposes. But so I can identify it now with my own name just by adding that one line in here, or just by adjusting the line. So I would make a new target here. So in hardware define folder, I would just say, Kraus 303 or whatever, and I'd include this, and then just make my own name and add the features I want to add, and ta-da! That's pretty it. But let's go down and look at the more under the hood stuff. So the F303 perif. This is more what the other vehicles would say. So if you were to do like an FMUV2 or 3 kind of thing, you would see all these things. So you'll notice the flash reserve is 26K on this one. So that's using the on the F303, it's using 22K plus 4 for storage. So it's reserving that ahead of time. And there's parameter storage, which is nice. So that's actually built right into the flash of the STM32. So you don't need an external EEPROM or non-volatile. This is the key, that when you include this, that basically changes how everything looks at this. That treats it as a kind of different device, which is nice. But you just your clock frequency, you can set clock timing stuff. You just tell how big your flash drive is. If you have multiple serial
It's
ports.
worth mentioning the clock frequency a little bit more, the oscillator. The one thing that I've worked with quite a few vendors bringing out new AP proof devices. And one of the things that often causes problem is getting the crystals right. And so we've now added support for putting 0 as the oscillator frequency. And what that means is it uses the internal oscillator on the STM32 instead of using the crystal. And that's particularly good for debugging. If you've got a crystal problem, you can turn off the crystal and just use the internal oscillator. So you don't need a crystal at all. You don't need to attach one and get it working like that, and then get it working with the crystal, because it's surprisingly common how often there are mistakes in prototype boards with crystals from multiple vendors. It's one of the more difficult things to get right. And so being able to specify a 0 crystal is quite useful.
Yeah. And then the UART stuff, this is very traditional to how other devices work, where you can have your UARTs in whatever order you want, and so serial. So this actually ends up being the parameter. Let me actually bring that up here. So if I was to go over to perf here and look at the parameters of this on my Cube Orange, I don't know offhand which ones are built into it or which features are on or off right now, but for example, you can tell it what COM port it is. So, COM port 1, 2, 3, 4 kind of thing. Yeah, so if you have ADSB or rangefinder and all these things, you just say, I want to use COM 1 or 2, and that's logically the first one or the second one. So this particular device, for the basic one, it's COM 1 and COM 4 is available. So it'd be serial ones. I'm sorry, not COM, serial 1 and serial. Oh no, I'm sorry. This is serial 0 on this one. So serial 1 and 2 are not available. The first one's for the GPS. Typically, the defaults are your first one's your debug port. Serial 1 and 2 is your telemetry 1 and 2, and then the next one would be GPS. So this particular target uses that as a default, just so the rest of the library kind of uses it. All the defaults kind of line up. But yeah, just setting the PA pins to say you want to up it low and set your SPI clock to PA5 or whatnot. You can look through all the other hardware defines you can see all the other targets here. These all have a hardware defined file for all targets we have. And they just basically just describe the hardware. And it's a lot easier to just take something that is similar to your device and just copy it and then just tweak what you need. You usually don't need to worry about too much about the process stack and stuff like that. Just make sure your pins match, and when you compile, it will sanity check a lot of those things for you. Speaking of which, why don't we do that? Why don't we compile something here? Let's see. I can't see my text. Let me just close that. There we go. No, not that. That's a bad one to run. Let's just nuke that. So if I'm trying to run a F303 dash, let's see, we can do the M. Well, let's just do the Cube Orange URN. So if you hit tab on that, you should get. Oh, it's not capitalized, but it still runs. So if your hardware defined was not correct, then you get all kinds of errors there. So I'm just running the target like normal to just grab this as whatever the directory name is on this list. So we could do the Matex 764 wing. Well, that's actually 743 perif. Actually, why don't we do that as an example? Let's change that to say Matex H743-perif. Okay. And then you just run AP perif, ROF AP perif. So this is interesting. The AP OSD was loading on that.
Yeah, that's just because of the include of the hwdef.dat from the cube orange, and that has the wildcard pattern for the OSD fonts. So it's embedding the fonts, but it won't actually link the OSD library, so you can't do anything with it. So it's really just wasting a bit of flash space.
Well, if it's not linking it, then it won't.
No, it will still embed them. It'll still embed it because it's a
the files get
data.
embedded. Yes,
the fonts
right.
will be embedded, which wastes flash space, but the library won't be.
Right.
The library will be built, I would expect, but not embedded.
So let's look up this target while it's running. So we can look up this. So on this one, it included the main Maytech, and then it undefined a few things. So the cube orange perf does the same thing. It just includes cube orange and then removes a few things. It does not have a fat file system, like I mentioned before. There's no SD card support. But here, it's a battery, it's a servo, rangefinder, ASD, ADSB. It just magically runs all those things and you get those features. You can also tell it how many instances that you want to limit for your system. And I think these have to be one, if I recall, for AP-Perf right now. I'm not sure how well it handles multiple GPSs and multiple rangefinders. It may actually work, but I don't think I've tried that recently. And one also nice thing is there's something here like the HAL AP-Perf ADSB port default. So if we go into here, so in this hardware, they probably have a label that says ADSB or something like that on port 3, on serial port 3. And the idea is we can go into in all of our defining here, we say if it's not, and this is how we use a lot of the defines. If we don't define something, it'll give you a default. But we're saying on this hardware, we do use it. So down actually, when we enable this in the library, it gives you the correct default value for that device. So for that particular one, instead of just using our global serial port 1, we said no, this one we want you to use serial port 3. So that's a neat little thing that we can. That's part of all of our libraries. Is a lot of them are like this. And, same thing with a BOD. So you can default 0 or whatever the parameters are. Yep. So let's how'd that build go? Yep. So it works. And that's that. So what did that give us? That gave us a build / Maytech and bin, and then there we have the traditional files here. But if we want to upload that over our device, you would like over Mission Planner, you give it the bin file. And that's pretty much all there is to it.
So what you were mentioning earlier about uploading the firmware, currently we typically use one of the user interface UI tools, and I completely agree that the idea that we should be able to do a mass update of all the peripherals. If you've got a whole bunch of ESCs, like 8 ESCs, or updating each of the 8 individually would be quite painful.
Yeah.
So I've actually been thinking there's a couple of ways we could do this. One is subdirectories on the SD card, where the subdirectory named after the string node name, and then you could have a firmware in there, and we could support a bootloader client inside RGPilot. So that's one approach. Another would be a TUMPFS. If we extended AP file system to have a temporary file system support, then you could actually FTP a firmware, Mavlink FTP a firmware to the autopilot into TUMPFS, and then send a Mavlink command to say, now please upload that file to all of the nodes, all compatible nodes. And it would have to know that the node was compatible with that firmware by using that, probably the string identifier, along with the board ID. And that would provide quite an easy way to do a mass update of your ESCs, for example, because I think otherwise it'll be quite painful.
Yeah, because in our aircraft, we actually have a we're going to have several AP-Pref devices throughout doing various tasks, and everything we can. We have like minimal other stuff. So it would be nice to be able to maintain that when you do an update, to just kind of have your whole system on ready to go, and then you just control them individually for parameters to make them do different things.
One thing we have done recently is we now log the firmware string and firmware version of every CAN device that UpDoPilot sees on the bus. We log that in the onboard log, and we can optionally send that over Mavlink as well, which is quite handy, so that you can then, is the new CAN-D message, CAN device message in the log. And that at least allows you to tell now whether your devices are up to date by what firmware they're running. But the next step of having an automatic update of the nodes, I think, is essential for, much more widespread and easier adoption of CAN devices.
Yeah, although all the information is available, it's just a matter of automating it, right? Because when we look at, like down here, when we look at this, we get version numbers and hashes and all that right there. So it's over the bus already. It's just a matter of the autopilot's just ignoring all that stuff right now.
Yeah. Well, it's logging it at the moment, but it's not totally ignoring it, but it's not using it to do an automated update. Right. And I think firmware update basically we need to implement the bootloader client inside UpDoPilot, so that it can go and it's the file. There's an API within UAV CAN for doing file transfer, and we need to implement the file transfer to be able to transfer a new firmware, put it into the bootloader and transfer a new firmware.
Well, and the beauty of this is, we make a library, and then we just include it on both systems, and they both have the same system. That's the beauty of this. It's all shared libraries.
It's already implemented in AP-Pref because it's already does allow.
Oh, that's true. I guess
it's already got the server side of it there to receive the firmware, because that's how we do updates currently. We're just missing the side within UpDoPilot to be able to send the firmware without using a GUI to be able to update firmwares from the autopilot without intervention from a GUI.
All right. Anything else? If not, that concludes.
Well, just a quick question. I mean, is there any hope of ever porting this onto hacker boards like Teensy and that sort of thing? Maybe some ARM-based Arduino or something like that.
Well, right now it requires Chibios to really for all of our parsing and stuff. So and so that's limited to our STM32s right now.
Yeah. Well, there is a Chibios port for Teensy.
There's Chibios for it, but we don't. All of our scripts are right now basically hard coded to only support STM32s.
So someone has to do all the work of the drive and putting the drive.
And that's based on that Chibios the hardware-defined system. It runs through scripts when you do the configure, how configure. I'm sorry, WAF configure. That's ran through scripts comparing the hardware-defined description against the chips. And so we only have knowledge of STM, or the tools only have knowledge of STM32s right now.
So no one's really looked at porting that across to other.
It's perfectly doable to do a different, a non-ST chip. We do recommend at least having 256K of flash for a peripheral node. We do have some nodes that are 128K, but it's quite tight, because you basically got two CAN stacks you've got to include. One is the bootloader and the other is the main firmware. And for reliable update, you really need two copies of that stack. And that limits, the amount of, you can't really go down to very small flash size devices. But yes, it would be quite a lot of work to do a non-STM32 target, and probably not worth it to put a lot of effort into other than STM32s, because they, apart from the current chip shortage of STM32s, is a bit of a problem. But apart from that, they're fairly ubiquitous and pretty good value.
It's just, well, you can just imagine this would be really useful for that community to have something like this, I think. So.
Hi guys, it's Buzz here. Just thought I'd butt in for a minute and say you're all wrong. It's already done and it works. Now I have a bleeding edge, very, very experimental port of ArduPilot to the ESP32, which is actually running on FreeRTOS, which has been around for a little while now. It's been around for maybe a couple of years. But about 2 weeks ago, I was able to just barely get a version of AP-Proof running on the ESP32.
Ooh, fancy.
So
Very nice. Congratulations, Buzz.
If you're interested in bleeding edge, nasty code that crashes lots, but runs on something other than an STM32, then come and see me. Back to your normal program.
Thanks, Buzz.
Yeah, thanks, Buzz. Yay, Buzz.
I guess just,
Alright.
I don't know if this is the right place to ask, but it's kind of related. Has anyone ever looked at running AFDX protocol or supporting AFDX protocol on ArduPilot?
FDX? I don't think I know that one.
AFDX bus protocol. It's an Ethernet based protocol that's used on big planes, but
I know nothing about it. So I imagine that a whole bunch of developers are now Googling AFDX, avionics full duplex switched Ethernet.
yeah.
Well, there's a Wikipedia article.
It's the backbone bus that Boeing and Airbus use. it's just that it's
Yeah, sure. Why not?
Ethernet based,
Let's
and
do
most
it.
of the STM chips now support Ethernet. So it would be
What's it called?
AFDX.
DX. Sure.
I mean, it's
Well,
Okay.
I mean, the
Well-
basic attitude of the ArduPilot project is to support anything for which there is demand from our users. So, if there's interest in this and if it's useful, and somebody puts their hand up to put the time in, then certainly. It does have to be something that, there is enough interest that it's worth maintaining, because typically the maintenance cost of additions like this is higher than the original development cost. If you'd like to, prototype support for this, at the moment we don't support Ethernet at all. On our STM32 boards. Obviously, we support it on the Linux-based boards where it's nice and easy to do Ethernet, but on the STM32 boards we don't. There is a couple of efforts. There is actually, in fact, effort underway to add Ethernet support on STM32 boards for ArduPilot, and I think that's likely to happen in the next year. But it's a little bit early to be given status updates on it.
Just when I see Tom, wiring a whole aircraft up with CAN, I mean, that seems, it's not outrageous to imagine that somebody at some point would want to hook up an AFDX component, although they're hugely expensive. A really high-end drone might want to work with an ArduPilot flight controller or something like that.
I mean, it seems like if it's 802.3, then that's super standard. It's just a matter of the data going over, I guess, and timing. But existing hardware seems to do it.
But I mean, it opens up a high band. You can get 100 megabits per second and low latency. So, would be really great to have.
Yeah, having so the problem where peripherals right now with Ethernet is you have a kind of a infrastructure hit with having Ethernet in each box. It makes your peripherals bigger. Right. So that with Airbus here, that's okay. You don't even notice that. But on these little small drones, that's significant. But these drones are being used. These unmanned vehicles are being used in many different ways now, and Ethernet is viable in many different solutions. So yeah,
I mean, it's not. It's just UDP IP. It's as simple as it gets. It's at the protocol level. So, and it's statically configured. So you don't really need to have like a full TCP/IP stack with ports and all of that stuff. It wouldn't be. I can't imagine it's any more complicated than Mavlink. At the end of the day, at the code level. So,
but go big or go home. Why have one stack when you can have them all?
But you could technically then hook up a ring laser gyro to an ArduPilot flight controller or something like that. Which sounds outrageous, but maybe down the road that's the sort of thing people would want to look at doing.
And there are cameras and sensors and stuff that are Ethernet only. just
Right,
because the,
right.
the sheer massive amount of data that they generate.
Right. Yeah. I mean, it'd be really great as a protocol for daughter, for companion computers, that sort of thing.
Yeah, and that's been the argument too, is the right tool for the job, right? Is the autopilot itself the one you want to be feeding hundreds of megabits of LiDAR data to? Or is that some sort of Linux computer that's
Yeah.
got gigs of RAM that can handle all that?
Well, it's a multiplex bus, so you could have lots of peripherals talking on that bus, including companion computers running software, flight software, and included on that bus would be the flight controller that needs to also get data or send data to those peripherals. So
Yeah,
yeah,
there's definitely a use case for it.
Mm. Just when I see you using CAN to do that, and then that's also something that's done on large aircraft, of course, as a field bus technology, but that's heading in that direction where you've got multiple peripherals on a multiplex bus and lots of data moving around. And it's not outrageous to think that pretty soon people will want that sort of bandwidth, for video data and all sorts of things.
Yep.
Or low latency, perhaps, is the other thing to consider.
Yep, indeed.
Anyway, I just seemed like the right place to throw that out there.
Yeah, thank you. Anything else? Is there anything on the YouTube channel or stream?
I'll just go and check it now to see if there's any questions that turned up on the YouTube channel, if somebody else has already been following it. And apologies to those on the YouTube channel if we haven't been tracking things properly. And just a second, I am checking it now. And yeah, it doesn't look like to be anything about the AP Proof talk. So I think we just need to thank Tom very much for his talk this morning, and greatly appreciate you putting that together. I know it was very short notice. Tom was only knew he was giving a talk a couple of days ago, and so very short notice to put this together. So we've got a little bit of extra time now, and I'll just stop the recording.